Hello everyone. I'm Dr. Samyukta S, Assistant Professor, Department of ECE at SJBIT. In this video, I'll going to explain you about the MOSFET. The MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. Okay, so it is a type of transistor which is called as a metal oxide semiconductor field effect transistor. Okay, so it is a type of FET that has an insulated metal oxide layer between its gate and channel. Fine, there are two types of MOSFET. One is called as a depletion MOSFET and another one is the enhancement MOSFET. Depletion MOSFET is called as D MOSFET. Enhancement MOSFET is called as an E MOSFET. Okay, so both of these MOSFETs are widely used in electronics, integrated and embedded circuits. Usually the MOSFET conducts current between the source and the drain. So the path for the current between the source and the drain is called as a channel. The width of this channel is controlled by the voltage that we are going to apply at the gate terminal. Okay, so let us discuss about the type of MOSFETs one by one. So the first one is the D MOSFET, that is depletion MOSFET. So depletion MOSFET is a type of MOSFET where the channel is constructed during the process of manufacturing. Okay, so in the D MOSFET, the channel will be constructed during the process of manufacturing, whereas in the E MOSFET, the channel won't be constructed during the process of manufacturing. So this is the main difference between the D MOSFET and the E MOSFET. Okay, since we are constructing the channel during the manufacturing process, here the D MOSFET can conduct between its drain and gate even though when the value of VGS, that is the gate to source voltage, is 0 volts. Even though we won't supply any voltage to the gate and source terminal, the MOSFET will going to conduct here. Okay, so therefore D MOSFET is also known as normally an on MOSFET. Fine. So these are the symbols of the D MOSFET. So this is an N channel D MOSFET. This is the P channel D MOSFET. Here each and every lines are representing the terminals of the MOSFET, that is drain, gate and source here. So this particular line is representing the channel here. So this channel is connecting the terminal called as a drain and source here. So since it is a connected line, it is representing that the channel is constructed during the manufacturing. Okay, so coming to the construction as well as the operation of the D MOSFET. So here we have two types. Again, it is an N channel D MOSFET. This is the P channel D MOSFET. So based on the type of channel we're going to use, it is classified into N channel and P channel here. So gate, source and the drain terminals are connected to the metallic contact here. So gate is isolated from the N channel, so by oxide layer here. Okay, so see all the three terminals are connected to the metallic contact. So since we have a metallic contact here, the gate is isolated from the channel. Means there is no direct connection between the gate and the channel in this type of MOSFET here. Okay, so hence this conducting channel is isolated from this gate terminal. So whatever the voltage we're going to apply here, directly it won't supply to the channel here. So due to this insulating layer, there won't be any current flow to this gate terminal. So the input impedance at this gate terminal is very high. So this MOSFETs are used in the applications where minimum power consumption is required. Okay, so coming to the working, gate and source terminals are connected together and they are connected to the ground. So what you can observe here, the gate and source terminals are connected together and they are connected to the ground. Therefore, the value of VGS is equal to 0 volts. Since both the terminals are connected to the ground, the value of VGS is equal to 0 volts and let us apply the positive voltage to the VDS, means between the drain and the source terminal. Now positive voltage is applied between the drain and the source terminal. So due to positive voltage, electrons in this N channel will attract towards the positive terminal. So in this way, current will establish in this N channel. So if we keep on increase VDS, the current will going to increase. At one particular point, means at the point of VP, peak voltage, the current will become saturated. Okay, so this is how it will going to work. So now let us supply the negative voltage between the gate and the source terminal. So now apply the negative voltage between the VGS, and let us see how the circuit will going to work here. So the negative voltage at the gate terminal will push the electron towards the substrate. Okay, so at the same time, holes in the P substrate will also get attracted towards the electrons here. So in short, during the negative voltage at gate terminal, the electrons will recombine with the holes, and the rate of recombination will depend on applied negative voltage here. So as we increase the negative voltage, recombination will also increases. So number of free electrons in the N channel decreases. So the flow of current also decreases. Okay, so this is how the D MOSFET will going to work when you supply the negative voltage at the gate and the source terminal. Fine. So next is the E-MOSFET. So as I've already told, E-MOSFET stands for enhancement MOSFET here. So why it is called as an enhancement MOSFET? Because when we apply the control voltage between the gate and the source terminal, the channel is formed between the drain and the source terminal here. So hence, in this type of MOSFET, the application of control voltage enhances the number of charge carriers in this region, and due to that, channel is getting created here. So this type of MOSFET is called as an enhancement MOSFET. Okay. So now let us supply the positive voltage between the gate and the source terminal by keeping the drain and the source voltage as 0. Okay, by keeping VDS as 0 volts, if we supply the positive voltage between the gate and the source terminal here, initially volts are the majority carriers in the p-type substrate. So whenever we apply the positive voltage at gate terminal, the holes near the oxide layer will pushed away from this gate terminal, and electrons, which are the minority carriers in P substrate, will attract it towards the gate terminal. At lower value of VGS, these electrons will recombine with majority charge carriers. So as we increase the value of VGS, the holes will be pushed more and more deeper into the substrate, and more electrons move towards the gate terminal. But as there is an insulating layer here, the electrons are not able to cross the oxide layer. So what they're going to do is they start accumulating near the oxide layer. So that layer is called as an inversion layer here. So this inversion layer will act as a channel between the source and the drain terminal. Now when VDS voltage is applied, then current, that is ID, is created and can flow in this channel. Okay, so the value of VGS at which inversion layer is created is called as a threshold voltage. For how much value of gate to source voltage the inversion layer got created, that particular voltage is called as VT. VT is nothing but a threshold voltage. Okay, so this is how the E MOSFET is going to work. But here, when the value of gate to source voltage is greater than the threshold voltage, then the width of the channel will going to increase. In this way, the application of the gate to source voltage creates a channel between the drain and the source terminal. Along with channel, there is a depletion region. When the value of VGS greater than the threshold voltage VT and VDS is equal to positive value, then as we increase the value of VDS, depletion region also increases. As the value of depletion region increases, then the channel width will going to decrease. Okay, so this is how E MOSFET will going to work.